This
housekeeping.
conference will now be recorded.
As a few words of housekeeping. Please mute yourself if you don't speak. If you have questions, put it into the chat box and we will take it from there. As I mentioned, we have reserved Q&A session after each presentations. Again, I would like to emphasize that this is a collaborative activity delivered to you with Scottish Developer International. So before moving on to the first presentation, I will pass on to Michał to say a few words to you as well. Thank you.
Thank you, Janusz. Thank you, Janusz, for this good introduction. So my name is Michał Sobczyk and I represent today Scottish Government and Scottish Development International. And today we have 4 companies, as Janusz mentioned, 2 from UK and 2 specifically from Scotland. So I'm here for you if you have any question about Scottish offshore wind capabilities, but as well if you are interested in different areas of energy, for instance hydrogen, I'll be happy to talk with you later today after the webinar, and also I will share later my contact details. So please don't hesitate to reach me out if you have any questions. Without any overdue, I would like to introduce first company, and we have 2 speakers from Empire Engineering, Andrew and Waiting. So I would like to introduce those our colleagues, and Andrew, over to you.
Good morning, thank you. Waiting will be doing the presentation. So Waiting, are you able to share your screen?
Hello everyone. Yeah, here's that. Can everyone see my screen now?
I can see that, Waiting. Yes, that's come through for me.
Yes, we do.
Cool, perfect. Yeah, right. So I'll start our first presentation here. So we're Empire Engineering, and this is Waiting Sue. So today we're going to talk about the automation and advanced technique for foundation design. Just a brief introduction of myself. I'm a structural engineer at Empire Engineering. I'm specialized in WTG foundation design and fatigue analysis. And alongside with me is Andrew Hodgson, who is a senior engineer in Empire Engineering, and he'll be covering the second part of our presentation. So let's get started. So brief to give you an overview of this presentation, I'll briefly talk about who we are as an empire, and to cut into the chase about WTG foundation optimization later on. So that covers how we select the foundation types and how we automate the foundation design process. So we'll be covering a little bit about a more concept on the cutting edge, which is the TP-less monopile secondary steel design, and also the advantage of PISA soil curves. And also at the end of the presentation, we'll be talking a little bit about our experience in offshore substation design. So a brief introduction of who Empire are and what we do. So these are our values. As Empire, we are a niche engineering consultancy, and our values are trusted because we've all been working on the major offshore wind farms around the world, and we're all experienced. We're specialists because we all have our own personal field of studies, and we're all specialists in this industry. And last but not least, we are all responsive, we're happy to help, and we all love engineering. So what we do is around the entire project life cycles, from the feasibility study, concept design, FEED design, to life extension, to commissioning of the offshore wind farm. So for example, we do a lot of concept designs around the world to help the bidders to win the bid, for example, like the ScotWind leasing round, and also the UK Crown Estate round 4. We do concept design for them. to give them the booster on their bidding round. And also we do a lot of feed design to help the developer to get from concept design to detailed design. We also do life extension jobs like helping out the current operating offshore wind farms for them to extend their structural life. These are the three main categories of MPART service. We do project delivery, we do concept and feed design, and we are specialized in. Sorry, am I muted? Right. So
no, we can hear you.
Cool. So who we help? Basically, we've engaged with a lot of the main stakeholders around the offshore wind industry. So, for example, we are the lead geotechnical engineer on behalf of Ørsted on two of the main offshore wind farms in the United States. We are also the foundation package manager for on behalf of SSE and Equinor on Dogger Bank offshore wind farm. And these are the rest of the stakeholders that we work with. So let's cut into the chase. We're going to talk about a little bit about the WTG Foundation optimization process that we do in MPART Engineering. So start with the foundation type selection. So the main question here is that if a developer doesn't know how to select their foundation type, given the fact that they have a very limited information at the beginning stage of their offshore wind farm development. So what we want to help is we have a systematic way to assess this. So at the beginning, we'll break down all of the possible offshore wind foundations, break down the pros and cons of each of the foundation type, no matter if it is an old-fashioned foundation or it is a emerging at the cutting edge innovative idea. So we list out all of these foundations and we compile a scoring matrix, or you can call it a register that covers the entire project lifecycle from the designing phase to commissioning. So for example, in the designing phase, we'll need to probably look at what is the track record of this offshore wind foundation. We need to look at how easy can this foundation get certified by a third party. We could also look at the fabrication side, for example, if there's any existing supply chain locally for this offshore wind foundation fabrication. On the O&M T&I phase, we could probably look at how we can secure this vessel and how easily to access this kind of vessel for this specific type of installation. So after we've done all of these risk register, or you call scoring register, we could do a quantitative assessment based on the pros and cons we listed for each of the foundation type, so we can know better about what type of foundation you'll need to select for your site. So at the beginning stage of the development, we'll tend to engage with the stakeholders for this offshore wind farm development, because we want to know what they really need, and we can tweak the weights of each of the factors around the project lifecycle to give you a tailored assessment. So we've done this for different projects like the ScotWind leasing round and the UK Crown Estate round 4. I'm now going to be a little bit geeky here, because we're going to talk about how we automate the foundation design. So if you're a foundation designer, you'll know DMV CSIM, which is a very, very powerful tool to automate, to do different analyses like optimum limit state or fatigue limit state. But not every foundation designer knows how to maximize the capacity of CSIM. So what we do in Empire is we created a very user-friendly Excel spreadsheet with VBA codes embedded in them for any of the user, no matter if you're amateur or if you're an expert, to key in the key parameters for the foundation design, for example, like the ocean inputs, the soil data, the turbine tower geometry, etc., to these Excel spreadsheets to enable the VBA codes to generate the JavaScript, which is readable by CSAM, to model it for you. So that this procedure can skip all of the tedious and error-making procedures that a structural engineer can make. So we basically skip all of the manual modeling parts of CSAM modeling, and we keep the error to the minimum. So also because within a offshore wind foundation, within the offshore wind site, there must be variation of site conditions, like the soil conditions from turbine location to location, or the met-ocean grids from the top of the offshore wind from site, or the bottom of the offshore wind from site, for example. So what we created is a folder structure that is designed for multiple foundations. So for a design of a foundation, you can pick up the right snippets within the folder structure to give you the right site information. So in that case, a designer can design more than 100 monopiles, for example, in a single run, and creating those models without any hesitation. So we've been also working using this in one of our studies, such as the Dogger Bank feed study that we did only a couple of months ago. So I'm now passing the presentation to Andrew to talk about the Fathom automating part. Andrew?
Thank you, Wei-Ting. So Fathom is Empire Engineering's own in-house developed design analysis tool. It takes a set of input parameters regarding the wind farm site defined by the user, and it will generate the optimum foundation design from those input parameters. Optimization is performed for the cost of the monopile and that can be based on our own internal cost database, based on our design knowledge and on industry knowledge, or it can be a specific database tailored to the project. Fathom allows Empire Engineering to deliver to clients the most cost-effective design for their wind farm in a very short time frame. So currently Fathom designs monopiles, however we are intending to expand this to jacket foundations as well, which will allow clients to compare which would be the most optimum design for their wind farm, whether that be a monopile or a jacket. Next slide, please, Wei-Ting. Another aspect that we've been heavily involved in is the TP-less secondary steel design. It's a relatively new concept for the offshore wind market. It eliminates the traditional TP, and at Empire, we really have been involved at this from the concept stage right through to installation and commissioning. So the TP-less monopile reduces the operational cost of the wind farm, and studies that we've undertaken shows that this could be a saving of between 6 and 10%. So it really is quite significant. The saving is mainly achieved by the elimination of a bolted flange from the traditional design, which is a costly offshore maintenance, and that goes on for the life of the project, so eliminating it really is a benefit. Savings can also be achieved during the installation, as vessel owners can optimize their usage of their fleet, so different components can be installed by the small and large vessels, which really will compress the installation program. The reduction of operational costs, well, not only are they good during the lifetime of the project, but they will make life extension more economically viable and potentially allow you to extend the wind farm's life beyond the initial design life. So you can really squeeze all the usage out of your wind farm. Next slide, please, Wei-Ting. At Empire, we've also been using the PISA method. So the PISA method is a relatively new analysis method. The project was started in 2013, but it wasn't made available to the public until 2020. It aims to optimize monopile foundations by taking advantage of additional soil resistance, which wasn't captured in the traditional API methods. And at Empire Engineering, we have delivered project to clients, taking advantage of these the optimizations PISA can bring. And these have really helped us reduce the cost of monopile and reduce the embedment length, which can speed up installation as well. We have the experience in-house to design foundations using the PISA method, and this approach will be crucial in future to delivering optimized designs. Next slide, please, waiting. Sorry, waiting, next slide as well. And the next one as well, sorry. So at Empire Engineering, we not only deliver turbine foundations to clients, we have a wide breadth of experience designing offshore substations as well. And next slide, please, waiting. So the design you see on the right was delivered as part of the Valorous concept design, and it allowed the client to get an understanding of the structural costs of the substation. The client was toying between a floating foundation and a fixed foundation for the substation, and our design allowed them to make a better informed decision about which concept would be most feasible for their wind farm. We conducted the full design of the structure, and that includes the jacket and the topsides. We performed an optimization of the deck and all structural members to give the client the most feasibly optimized design. At Empire, although we've been working, we've done a lot of concept designs, our team have quite a lot of experience from previous projects that they bring also to Empire Engineering. So we do have a lot of experience in this area as well. And next slide, please, waiting. So we've talked about our experience, but like, where have we actually worked? So if I just give you a brief overview of where Empire Engineering have worked. So currently we are working on the Dogger Bank farm. We are all, the multiple members of the team are heavily involved in this, and we are working across all 3 Dogger Bank sites. We've also done work for various clients off the coast of France and also in Germany. Next slide, please, waiting. As well as this, we've been involved in Northwester 2. This is where we've gained a lot of our TP-less experience. Arcadis as well, and there's a couple of others that we've been heavily involved in. Next slide, please, waiting. The one to pick out here is that we've done the Crown Estate leasing round 4, which was right at the beginning of the project. And also we have experience in floating wind. We were involved in a floating wind farm off the coast of France, just at the bottom there. Next slide, please, waiting. Experience not only is in Europe, we've also done quite a lot of work in the Eastern markets. We've done a couple of wind farm concept designs for Japan, Korea, and Taiwan as well. Next slide, please, waiting. So I'll just finish our presentation by talking about Foundation X. Foundation X is a conference series run by Empire Engineering. Next slide, please. It's a technical conference for engineers. Talks and seminars are given by industry-leading experts from around the world, covering all areas of offshore design, installation, and fabrication. The first conference was held in 2019 in Bristol, and last year we moved Foundation X to a digital conference due to obviously the ongoing pandemic and people's inability to travel. All the talks from last year's conference are available on our website, and they're free to watch. I would highly recommend them. It's a great way to learn more about your own area of expertise and broaden your understanding of the wider industry. So I definitely recommend having a look on our website. There will definitely be something on there to interest you. Next slide, please. Thank you very much for listening, everybody. We're happy to take some questions at the end of the presentation.
Thank you very much.
Thank you, gentlemen, for this interesting presentation and very impressive track record in designing foundations.
Thank you.
And any questions? I am monitoring the chat box and I can see no question at the moment. But I'm very glad that you raised the PISA method, as this was also raised by some of the developers whom we've been talking to when we were preparing the scope of this webinar. So thank you for this.
Okay.
If there are no urgent questions, I would like to introduce Chris from Pangeo Subsea. Some of you will know Chris already, as he was our speaker in one of the first webinars this year. And Chris is going to speak about some acoustic techniques to add foundation design. Chris, over to you.
Thanks very much, Yannis. So yeah, and good morning, everybody. I'll just start sharing my screen. Okay, hopefully that should be visible to everybody. Okay, yeah, so I'm Chris Holland. I'm the Business Development Manager for Pangeo Subsea, and today I'm going to give you a presentation based on our 3D acoustic subsea imaging technology. As Shannon said, I actually presented at one of these conferences two months ago, so I appreciate there might be some of you that saw me and heard me speak then. So obviously, then we looked at, I guess, our general capabilities as a company and the technology and services that we can deliver. And this presentation is now obviously tailored towards how you acquire that data and then how those results aid in the, I guess, foundation selection and then foundation design and location selection as well. So thankfully, the team at Empire Wind gave me quite a good platform to now present. First of all, we want to talk about the importance of survey and why developers do carry out surveys and why I feel they should be carrying out more high resolution, more detailed surveys than they currently do. I guess there's three reasons why you carry out surveys. Number one, obviously those images there are quite drastic, but really it's a risk mitigation. So really to avoid catastrophic failure. Thankfully, they're quite rare, but they can and do happen. Second reason, really, is to ensure an efficient installation of your foundations or your cables, whatever you're installing on or under the seabed. You want to make sure that it's as efficient as possible. When it comes to foundations, obviously you want to mitigate any refusals of those piles at your locations, ultimately to make sure that there's no overrun in time or costs. And the third reason, obviously what I'm really presenting about today, is to aid that foundation, I guess, first of all, the actual location selection, so making sure that there's no anomalies or shallow geohazards which would impact that installation. And if there is, clearly you can move them rather than hit those during installation. Secondly, really to help in the overall design of those foundations. So not only, I guess, if you put it in monopiles, the thickness of those walls, just in case you're going to encounter buried boulders, but then also what depth that you need to target. I won't dwell on this. There's a lot of people that know much more than me. So really just obviously breaking these the various methods of foundations into two categories here. Really your fixed bottom structures, so really looking at your jackets or your monopiles. They're obviously your survey design will need to account for the fact that they're going much deeper into the seabed. And then the shallower foundations, typically obviously your floating wind farms where it's an anchor. There, your survey penetration only needs to be sort of 5-10 meters. You're going to have much higher resolution data as well, and there you might be sort of looking at a larger spatial survey. So Pangeo Subsea, we are a service delivery company. We specialize in subseabed 3D acoustic imaging technology. We've developed two technologies to support the offshore wind farm development. The first one is the acoustic corer, so that's at the top there. Both technologies acquire 3D volumes below the seabed in high resolution. The acoustic core is an actual tripod mounted system. It's placed onto the seabed and it acquires a 12-meter wide, and then really depending on what lithologies you're surveying into, very typically is about 40 meters in the Baltic, probably 50 plus meters that we achieve there. And what it ultimately delivers is this 3D volume below the seabed at your pile location, from which you can determine the location of all buried boulders, obviously very important, but then also map those lithological boundaries for the entire footprint of your foundation, and then ultimately for the entire volume. Then our sub-bottom imager, so this is a system again using 3D synthetic aperture sonar, but in this instance it's now acquired in motion, so very typically acquired from a work-class ROV. And what it's achieving there is a 5-meter wide footprint depending on lithologies, again, 5 meters very typical in the Baltic, probably 6-7 meters in the Baltic in depth. And again, what that's going to achieve is the 3D volume to map all your buried anomalies again, so your buried boulders, but then also again your lithological boundaries. So we're able to then ascertain, all buried anomalies, but then also the 3D depth of those horizons at your foundation locations. Just a bit more about the sub-bottom image. This is the first technology I'll run through with you. Like I said, it produces a continuous high-resolution 3D acoustic volume below the seabed. It is a true 3D volume, although here I've obviously just got a few sort of 2D slices to show you. So this is looking into the volume. So clearly this is a cable survey. We're going along the track here. This is your seabed here. That's where your cable is. What we call the plan view. So we've sliced through the seabed then to find the top of the cable. Exactly the same when you're looking for boulders or lithological boundaries. Slice through the data set looking at these 3 different views. And then the side-on profile here. So here's the seabed. This is the cable that you can see there. So you're looking side-on there then. Sub-seabed resolution to 5 centimeters, 5-ish meters depth, up to 6-7 meters in locations. And what it's mapping there is the acoustic impedance. So when you're going from a sand to a clay, obviously there's an impedance at that boundary. Exactly the same if you're hitting a buried cable, a buried boulder. It's the difference in impedance which it's detecting. So just quickly really looking at the survey methodology, depending on the foundation design. I guess here we're now looking at your shallow, given that the penetration is only 5-6 meters. We're looking at those anchored foundations in this instance. And there, I guess you would employ 2 different methodologies of survey. One is if you already know those anchor locations, you're relatively certain that you want then the 3 or 4 anchors to be located in these locations. Then really it's a very small targeted survey. Typically the surveys that we've carried out to date, targeting those locations, you're looking at about a 20 by 20 meter box or a 20 meter diameter circle. There you would acquire a 3 meter line space with the sub-bottom imager across the entire survey location, obviously diminishing lengths of survey lines. Here, the most efficient method of acquisition is from a work-class ROV, just showing you one here with the sub-bottom imager here in its ROV skid. And there, obviously, we're building up a 200% overlap of the subsea to ultimately enable the detection of any buried anomalies and those lithological boundaries. It would still obviously provide you space for microsighting within that box. So if there is any showstoppers or any large boulders that you need to avoid, that 20 by 20 meter box, it still gives you space to move around within that. If you're not exactly sure, or if you're doing this up front before you've really honed in on the locations that you want for your foundations, then typically you'd acquire a much larger survey area, a few hundred by a few hundred meters, 200 meter by 200 meter box. When it starts to come to a larger location, then you can start to acquire the data from a tow platform. So this is our sea kite. It still houses the sub-bottom imager. It's just a different application. So rather than it being attached to the ROV, it's now housed internally within the towed wing. So allowing you to tow at sort of typical survey speeds, 4 or 5 knots. So obviously covering this larger survey area much quicker. So you're still delivering that 3D volume. You'll still be able to locate all those anomalies and those lithological boundaries. But at this instance here, you're acquiring over a larger area to enable that more targeted foundation selection criteria. The results from that survey, so these are just looking at individual survey lines now. So these are the top down, we're sliced into the seabed here. So as you're slicing through the seabed, you can see on the individual survey lines here, slicing through until we locate the boulders. So here are numerous boulders on this line. Thankfully, there's only one. And ultimately, yeah, mapping its XYZ position so you know exactly where that boulder is, and then clearly getting very high resolution dimensions as well, at 5 centimeter resolution. The technology is. Secondly, then, obviously looking at your shallow lithological boundaries. So here we're looking at the side-on profile. So you've got the seabed here, and then a lithological boundary. This is actually, it shows up very clear because this is actually bedrock that you're imaging here coming up. So yeah, if you're looking at what depth you need of your sufficient sediment to hold your anchor in place, your suction anchor in place, then clearly you need to make sure that you've got sufficient coverage over that entire 20 by 20 meter box. And if you're doing the upfront survey over a larger area, then clearly knowing those thicknesses of soils throughout the area will help you decide that more targeted location. And then just looking top down, this is then the slice through the seabed. So as we start to hit the bedrock, clearly it's got a very strong impedance compared to the stand above. So it stands out really clearly. When you start to stitch those survey lines together, so till now we've only looked at individual survey lines, that 5 meter footprint. Now when we start to overlap those survey lines and look at the broader picture of your 20 by 20 meter box or your entire survey area, you then get to start to build up a very clear picture of exactly what's going on below the seabed at your foundation site. Here on the right, this is the actual sub-bottom imager data. So here you can see everything that we've mapped below the seabed. So here you're looking at about 50 meter wide footprint there. Clearly, we're going to identify all buried boulders within that site, but then also we've actually identified the pipe and the fiber optic cable that run over the site as well. So that's boulder shallow anomaly mapping. On the left here, it's the same site, and now what we've done is we've overlaid the boulder locations, but they're really small on this image. But what you see in here is a shallow soil, what's called an isopack chart. So this is showing the depth from, say, your sand to your clay or vice versa. And what we've then done is we've mapped that depth in lithological changes over the entire footprint. So you know definitively what soils you're going to be trenching into, if it's your cable, or in this case, what lithologies your foundation is going to be placed into. Secondly, then introducing you to our acoustic corer. Now, obviously, this is used for your deeper foundation, so your monopile or your jacket pin pile locations when you need to acquire this high resolution data, but to much greater depth. The acoustic corer, like I say, it produces a 12 meter wide diameter cube of data that penetrates anywhere from 30, 40 to about 60 meters penetration into the seabed. We've actually done numerous projects within the Baltic, and we've done to date one within the Polish Baltic, and there we actually achieved upwards of 60 meters penetration. It houses two payloads, two acoustic payloads. You've got a low and a high frequency, so the sub-bottom imagery is all high frequency. The acoustic corer now houses a high frequency, so exactly the same high frequency chirp projectors that the sub-bottom imager has, but also then has a lower frequency projector package to image much deeper into the seabed. What we're then mapping, I can show you here, and what you really want to start to use the acoustic corer for is correlation of your geotechnical results as well. So I'll move on to that in a couple of slides, but that's what you're looking at here is obviously your geotechnical data here. You're looking at the acoustic package here and being able to match up those horizons that you see in there and really extrapolate those geotechnical properties throughout the core. Survey methodology, very simple or straightforward for a monopile. You've got a single location for that foundation. You would place the acoustic core centered on the center of the pile location. and acquire that data. The acoustic if you acquire any, if you locate any anomalies within that, which you can't really pile through, the results are all given offshore within 24 hours, so you can start to daisy chain those to overlap until you find the suitable location. When it comes to jackets with numerous pin piles, this is an example of one we did at Block Island in the USA. There it starts to get a bit more tricky now. At Block Island, there's only 5 turbines going in. So acquiring an acoustic core, each of those 4 legs, so 20 sites in total, was very achievable. When you're looking at wind farms with 100 or so turbines, acquiring 400 cores would, yeah, you'd start to run into a very long campaign. So there you need to think a bit differently, and rather than acquiring 1 core at each pile location, which is the only way of mapping everything that's there, you then need to start thinking about maybe 1 core at each turbine location. And then what we can do is we can carry out a statistical analysis throughout the site. So there, the statistical analysis will look at the spatial distribution of those boulders, but then also the size of those boulders located in the different lithological packages. So if you know you've got a certain geological package which contains the majority of the boulders or the majority of the very large boulders, we can then start to map that geological package throughout the wind farm. So it actually might turn out that you don't have this problematic geological package throughout the wind farm. So actually those locations that you install in that don't have that package are actually much less risk. I'll just quickly show you the actual results that we achieve here. So this is the 3D volume now. So obviously we can start to play about with it. Here we're pulling down through the data, but you can see here, so this is the seabed. These are different lithological packages here that we're encountering. And as we start to pull through, you'll then start to see the boulders mapped within that core. Now, from the high frequency data that we achieve about a 15-meter penetration. From that high frequency data, really we can see within reason pretty much any boulder that's within there. 10, 20 centimeter diameter to 15 meters. When we switch over to the low frequency projector, obviously we start to look at that from 0 meters depth as well, just so we get that correlation between the 2 data sets. But it really obviously comes into its own when the high frequency data drops out at about 15 meters. So then we're relying on the low frequency from 15 meters to maximum penetration, 40, 50, 60 meters. There, the resolution of that data does diminish with depth, but it's mainly its ability to differentiate 2 boulders that are close together rather than isolated boulders. So you're starting at 30 centimeter diameter boulder, and here you can just see it's mapped now, auto mapped all boulders within that core to the entire depth. So 30 centimeters depth, diameter, 15 meters depth, and then obviously it does increase then with depth as you get to the base of the core. The results of which, well, clearly it's an anomaly map for all anomalies located within the footprint of your pile to the entire depth. As I said at the introduction of the acoustic core, then you can start to integrate your geotechnical results with the acoustic results. So when you start to see the horizons within the acoustics, you can then start to extrapolate those geotechnical properties from that singular point of your CPT or borehole across the footprint of your pile location. So obviously with a 10-meter wide monopile, what you have at one location within that pile might not necessarily have the same geotechnical properties when you move away if a horizon dips out, but the acoustic core enables you to extrapolate that data throughout. This is an example of the pin piles at Block Island. There, obviously, we were able to locate some buried boulders which would have impacted the installation. So the client simply just microsited that. They just picked a slightly different location within that core to move their piles to. And then some spatial maps here just showing you the distribution of a monopile. So here in blue is the footprint of the monopile, in red is the footprint of the acoustic core, and then just the ability to obviously locate all those anomalies within that. So ultimately, if you know there's a lot of anomalies within that monopile location that you can't necessarily move, it'll just help you then ultimately design that monopile slightly, or the piling pressures that you're going to put on to obviously make sure that you don't get any refusals at that site. That's all I had. Thanks very much for listening. I'd love any questions you might have.
Thank you, Chris, for your terrific presentation. Before we go to any question, if you have to Chris, I have a question for our colleagues from our colleagues to the previous speakers. So the question is, what are the challenges for TP-less MPs? Are they longer, heavier than equivalent MP? And Wei or Andrew, if you could answer this question.
Yes, sure, I'll take it. I've been quite involved in the TP-less design. Are they longer and heavier than the equivalent monopile? No. So the section sizes of the monopile do not increase because you've gone to TP-less, not necessarily, and the embedment depth doesn't increase because you've gone to TP-less. What does increase is the lift length, because previously you would be lifting the entire foundation in two sections. You would have the monopile end and then the TP-less. Now you have the entire structure that you need to lift. So that's one of the difficulties, is lifting the entire structure. Now, for shallower sites, this is not really too much of a problem. You've got the bigger boats can lift the longer ones anyway. So fusing the monopile and the TP together in one lift is not really a problem. The site that we looked at in one of the concept studies, the depth we took for it was 35 meters water depth. I cannot remember off the top of my head, unfortunately, what the embedment length was, but we were quite on the limit of what installation vessels are capable of at the moment. So that's kind of a rule of thumb for at the moment. However, having said that, we do expect kind of installation vessels to increase their capacity over time, as there will be a drive to increase the length of monopiles in general as we start looking at deeper water. So that depth will start to increase, but we saw that we were quite close to the capacity of the lift vessels at 35 meters. The second thing to consider and it's maybe not so much of a major consideration when you go to TP-less, is you end up with more attachments onto the outside of the TP, and these need to be carefully designed for driving fatigue. So you can't just put stuff on the outside of the monopile, hit the monopile when you're installing it, when you're driving it, and expect them to still be there at the end of it. You have to carefully design this. Now, traditional monopile, that has attachments on the outsides anyway, usually for the boat landings. You just increase the number of attachments you have for the TP-less. So that's another consideration that we had. And then there's other smaller stuffs around tolerances and that sort of thing, but they can be achieved. They're not such major problems.
Thank you, Andrew. If you have any other question to Andrew or Wei Ting, please put us in the chat zone, or of course we can talk after the webinar. And I didn't see any questions at the moment to the Chris, but of course there will be additional session at the end of the webinar. So take your time and if you have any question, please ask us. And I would like to go for our third speaker, and it will be Eric Finner from Smulders. So Eric, over to you.
Good morning, everybody, and welcome to this session. I'm going to start sharing my screen now. One moment. Here we go. So once again, a good morning to you all. My name is Eric Finet. I'm the Business Development Manager for Smulders. And Smulders is a long-time established company in offshore wind. Our first project dates back from 2001. It was the Hornsrev 1 project in Denmark, where we fabricated the monopile transition piece foundations at the time for Vestas. To give you an idea, the weight of the transition piece was 60 tons, 60. Now transition pieces are 600 tons. So this is the evolution in 20 years. Since then, Smulders has fabricated over 2,000 transition pieces and almost 200 jackets. Smulders is also active as a fabricator of substations, both the jackets or monopile foundations for the substations as well as the topsides. On this picture, for example, you see the two Gemini platforms for the same Dutch wind farm, and also Deutsche Bucht. You might have read that yesterday Iberdrola awarded the contract for the Baltic Eagle in the substation in the Baltic Sea to Smulders in combination with our partner NG Fabricom. Today, I'd like to discuss with you a few tips and tricks, a few, I would say, knowledgeable facts on design foundation, and then specifically for serial production. I started my career in oil and gas, and I worked for more than 20 years for several oil and gas fabricating yards, some of the largest in the world. My last project was a production facility, more than 125,000 tons. So I came to Smulders in 2014, and at that time the transition pieces were weighing 300 tons. So I said to myself, Eric, this cannot be very complicated. The only difference is that oil and gas fabrication structure is usually a one-off, or is almost every time a one-off, whilst offshore foundations for offshore wind, they are produced in series, and quite larger series. And the largest series Smulders produced up to date was again this Gemini project, 160 units. It will be taken over by Dogger Bank, where at this moment we are going to do 180 and probably another 87 to follow. So serial production is really a very, very different style of production than one-off production. I think if I see to yards in Europe, but also in Asia and other areas of the world, most of these yards are former oil and gas yards. When it goes wrong because they have not counted for all the specific items regarding to serial production. For focus points I like to discuss with you, innovation, of course. You cannot talk about offshore wind when you do not talk about innovation, but what does it mean for serial production? Integrated engineering, logistics, and think automotive, the mindset you need for serial production. Innovation, as I said, innovation is the buzzword. If you don't innovate, you know, they think you have no role in offshore wind. Well, ladies and gentlemen, I can tell you, since 2001, Smulders has performed more than 40 offshore wind projects, and I can tell you they were all different. There was none project that was similar to the previous one. Lessons learned, of course, remain important, but if you only, I would say, steer on your previous experience and you don't innovate, it will not work. On the other hand, equally important, offshore wind industry, in my opinion, is a rather conservative industry. Progress happens, but step by step. We don't take large leaps, especially not, I would say, the big European utilities. We don't take big leaps, but every project is different than the other. And innovation, of course, plays a very important role. Integrated engineering, I call it a balanced act. We have seen great designs, innovative designs. Later, we saw that they were a bit too innovative, as they were very difficult to fabricate, and then later on impossible to install. So what I want to say here to the designers, I touched upon this subject at the Fabrication X in 2019 in Bristol with the guys from Empire Engineering. You should look to all aspects of the product chain, the fabrication chain, when you design your offshore wind foundation. Weight, for example. Some developers focus on weight. Then I always ask the question, what is the most expensive? Is it a hole in the plate or a whole plate? We see some designs where weight is saved by providing a hole in the plate, but what do you think is most cost efficient? To leave the plate as it is, or to make a hole in the plate? The whole plate or a hole in the plate? This is something you have to weigh as a designer. Another issue we see is the use of standardized items. We all want to innovate. I come back to my first point. We all want to innovate, but sometimes the innovation is too fast, and the innovated items cannot be produced in series. So the fabricator has to wait until some supplier of some new equipment is up to speed with the supplies he needs to deliver. Compare it a bit with the vaccines. Yeah, they were very innovative vaccines, you know, but you see in all countries all over the world that the supply is, you know, is getting some hurdles. And for serial production, the same as for saving lives in this pandemic situation, it costs money, and unfortunately, it also costs lives in the latter situation. So, integrated design and engineering, please also look to the fabrication part of the product chain, we need a continuous flow of parts. To give you an idea, a transition piece contains about 7,800 parts, but they all need to be there if you want to deliver the transition piece. And Smulders delivers about 1 transition piece a day or 3 a week if they become very big. So that means that every day you need those 7,800 parts, or you can not deliver at the end of the day. So I'm asking a proactive attitude from the designers, yeah, that it makes serial production of what they have designed and engineered possible. A third item I like to bring to your attention is the importance of logistics. And I think that logistics, supply chain management is one of the biggest, the major difference between serial production and one-off production. I can speak from experience. I was project manager for a large fabrication platform for oil and gas, and also for one of the first substations for the German offshore wind market. We never saw so much importance in a good working logistic plan and a good working supply chain. If you order something, you need to order it 80 times. If you have 80 foundations or 50, so the company you are ordering with must be able to deliver that day by day in the correct format without damages, which is working. We have to be aware that you know, if one of these 7,800 items is not there, you can simply not deliver the foundation. So as you can see on the screen, the delivery time and budget importance of stalling logistics cannot be underestimated. And then last but not least, the mindset you need as a serial fabricator. It's basically the same as when you are a car manufacturer. Even I think that people that used to work in European car manufacturers can be good colleagues of offshore wind foundation fabricators. Yeah? They have this knowledge on serial production, and they can be an asset to the company. A few, I would say, practical tips to designers, but also to developers. First of all, and this is really important, especially nowadays with the shortage of all kinds of materials, metals, chips on the world market, is avoid using exotic materials. It makes no sense to use high tensile steel for offshore wind foundations, because for loads and fatigue, Z quality or E quality brings no added value. On the contrary, these materials are very, very, very difficult to get, especially now, but in the required series. Also, as I already explained, we can have a standardized product, but if it needs to come from the other end of the world, where transport and handling are a risky business, it doesn't help the serial fabrication, and it puts a risk on the on-time delivery of your product. Clustering. I know that some people believe in clustering, that you can further optimize your foundations. Yes, this is undoubtedly true, but look to the risk that the fabricator needs to use different materials for each cluster, and this can again jeopardize the timely delivery. So you have to ask yourself, what is the advantage I can reach by clustering, and what is the risk of delayed delivery because of the fact that we are working with more unique items than when there is a possibility to standardize most. And then the last point here, the long lead items, especially with the current situation on the world materials market, this really becomes a concern that some items, you know, have to be ordered very well, very early in the fabrication process. Then the fabrication phase itself, also here, serial production requires some different thinking. I talked about automotive thinking, car manufacturing. Well, there you have the big choice between your in-house manufacturing and subcontracting of parts. LLI Candice is long lead item. That means that is an item which you need to order very well in advance because of long delivery times, long lead items. Coming back to supply chain management. Supply chain management is something else than buying goods. We are talking about long-term relationships. Smulders has a number of suppliers, of course, but most of them were with us since the very start of our activities in offshore wind. Not all suppliers, you know, see that from the first glance. So our purchasing department, our supply chain department, is speaking every day with the suppliers and explaining them what specific needs we have as a serial producer of offshore wind foundations. Also, your supply chain, is an integrated part of your production process. It must be treated on the same level as engineering, on the same level as installation in an EPCI environment. As your labor force, your workforce, your organization, it's a very substantial and important part of your business, and you should treat it equally. Look for alternatives. What is my plan B? You know, you need to monitor the situation much closer than in a oil and gas one-off fabrication environment. And this is then a few words to your listeners that are suppliers and subcontractors. I would say mirror of what I just explained. Try to familiarize yourself with serial fabrication methodology, with industrialized production. Think automotive. When you offer as a supplier or subcontractor, also pay a lot of attention to your logistics, upstream and downstream. The logistics from your suppliers, but also logistics to the serial foundation fabricator. There is not everything goes well in this world. We are only humans, so communication is very important. We have some flexibility in organization, in organizing our activities, but once the train is rolling, once the train has left the station, you know, every day we need to deliver. As a supplier and subcontractor, we depend on your timely delivery, your flawless production of supplies. And if something goes wrong, you know, think proactively and warn us in a very early stage, and then we can work out a solution mutually. And then I would say a few generic but very important issues as well. As a serial producer, fabricator of offshore wind foundations, we are confronted with the requirement from the industry on sustainability. And Smulders has obtained all sustainable goals from the United Nations Treaty in that respect, but of course our supply chain is also part of this exercise, of this effort. Yeah? Social responsibility. We cannot afford that one of our suppliers or subcontractors, you know, comes in the newspapers with news that you know, he has not taken his responsibility as a contractor. This will shine also on Smulders, and this is not something we can tolerate. And believe in your industry, and I would say be part of the energy transition. Smulders produces almost 100% of its electrical power by themselves. We have 100% renewable energy we use in all our factories. So we are totally submerged in the industry we are working. This is a picture of our yard in Newcastle, where we have produced almost 100 jackets now. And with this picture, I like to conclude my presentation. Thank you very much.
Thank you, Alex, for this insightful presentation. Before we'll continue with our next speaker, there's a question to you, Chris, about the acoustic core. So if you could take on this.
Yeah, certainly. So the acoustic core, yes, I guess it can be applied for UXO identification as well. I guess typically you would have carried that out prior to installing something onto the seabed. So obviously the acoustic core is placed physically onto the seabed, so you would require some alarm certification of the immediate seabed. However, yeah, appreciate magnetometer surveys only have a certain depth of investigation. So if you did have a deeper buried munition risk, absolutely the acoustic core could achieve that. Typically though, yeah, the sub-bottom imagery is used as part of the UXO survey methodology. So you have your magnetic targets. Obviously, that's a very large target listing that you would have. Anything that's ferrous below the seabed, you can't really discriminate with a magnetic survey. So the acoustics that you would apply would typically come from the sub-bottom imager and be acquired as part of your ID and C phase. So you acoustically image each of those magnetic targets, take a look at its acoustic size and dimensions, and ultimately reduce that target listing using the acoustics from the SPI. But yeah, in short though, yes, the acoustic core can also carry out that function.
Thank you for clarification. So I know this was one question. So if we need to talk, we could schedule a call after the webinar. But thank you, Chris. I didn't see any question to Eric at the moment, but you know, please don't be shy. There'll still be a moment after the last speech to have any questions. But if you would like to talk directly to Eric or any other speakers, we'll be happy to schedule one-on-one call later this or next week. So I would like to go for our last speaker, and Andrew it will be Andrew from South Ocean. Andrew, over to you.
Well, good day to everyone. Thank you, Mikhail and Yanis, for the invitation for us to be able to present Foundation's capabilities, services, and experience. So I'd like to start off with a little bit about who we are and where we're from. Our main office is just west of Edinburgh in Scotland. We're originally part of the Wimpey Corporation originally back in the early 1960s, but then towards the early 90s, we actually split out from Wimpey Labs and Wimpey Geotech to form CMark Systems. The Wimpey Corporation developed and introduced the concept of offshore grouting during the 1960s, where in the Persian Gulf we grouted our first offshore platform on the Zakum oil field. Excluding Arlo Bank, which we grouted in 2003 for Denzit at the time, our first solo offshore wind farm was in 2010, which was the Ormond offshore wind farm in the UK, which was at the time the largest single installation of jackets, which 31, 32 jackets on that wind farm. Since that time, we've grouted over 1,500 wind turbine generators, foundations, and offshore substation foundations in Europe and overseas. We're currently working off the northeast coast of the UK in just offshore Scotland on 2 projects, and we're in Taiwan as well, working on a project, as well as our other offshore oil and gas projects around the world. So what do we do? Primarily, we provide grouting services for foundations, for the fixed bottom foundations in offshore wind and oil and gas and tidal. We also provide inspection, repair and maintenance of offshore assets, as well as solutions for strengthening, modification, repair and the decommissioning of offshore assets as well. We also have a range of products, primarily fabric formworks for offshore wind. That could be for pipe and cable protection, or for support of J-tubes, exiting monopiles. In other sectors, it's typically to correct freeze spans or to protect pipelines or cables. The image here is of our ROV connector range, which has become pretty much standard in offshore. So offshore grouting, we'll talk a little bit about our experience and then finish off with a short case study on the Beatrice wind farm, which we grouted back in 2017. So typically we've come across 4 types of foundations: jacket tripod foundation, the monopile foundation, the gravity base, and the floating. Of those jacket and tripod foundations, the variations within that are a grouted skirt pile or a grouted pin pile or a suction caisson. This being the skirt pile, where the pile is driven post installation of the jacket or the jacket being placed on the seabed. This is a pre-pile solution where the jacket is lowered in with stabbing legs. And then this is the suction caisson. The orange identifies where typically you grout in all of those instances. On the monopile, there is the fully grouted TP, the bolted and grouted TP, the bolted TP, which is ungrouted, and the mono bucket, ungrouted TP, which is a monoblock solution. Gravity-based units are typically ungrouted. In oil and gas, you would find a level of under-base grouting in order to assure some even load distribution. But typically in offshore wind farm, a lot of ground preparation goes ahead before gravity-based foundation is placed. And then floating, there's no grouting, or we've not seen any grouting up to this point. So grouting, when we talk about grouting, when I first joined Foundation, I thought grouting was limited to what you did with tiling in the bathroom. But grouting is essentially the mixing of cementitious products and for the fixing or repairing of offshore foundations. And at Foundation, we typically have 4 classes, which we split into low, standard, high, and ultra high. For low strength grouts, these are typically used for suction caisson grouting or for under-base grouting of gravity-based structures. And then standard would be a jacket pin pile, as in Ormond or Thornton Bank, or more often than not for member infill on repairs. High strength grouts, typically they've been designed for the range of 70 MPa to 100 MPa, and that refers to the 28-day strength of the cube, which is crushed. And then ultra high strength grout, which is anything really above the 100 MPa mark. OPC, which I talk about here, is just an acronym for the ordinary Portland cement. So common offshore construction grouts. This is just a few of the ones that we see a lot of, and I would add that there are more coming in. There are plenty of material developers out there who are looking to certify their grouts for offshore wind use. But typically at the moment, for construction grouts, they're in the 3 categories of standard, high, and ultra high. That's the Ducret S2, the Master Flow range, the Seeker grouts, and the Shifu grouts, which are Taiwanese grout. So if we talk a little bit about the type of grout to the type of foundation, for a jacket or a tripod, for grouted skirt piles, then we would see a high strength grout, which are around the Ducret S8s, the Masterflow 9800s, or the Seeker 3620, which the Seeker grout 3620 is the old brand name of that was the Parex 100 Newton grout. And then if the designers specify the grouted connection to be stronger than 100 MPa, we would see the likes of Ducret S5R or Masterflow 9500, the Shifu grout U799, or the Seeker grout 3500. For grouted pin piles, I touched on it earlier, Ducret S2 or OPC have all been used in the past, and then also the Ducret S8s, the 9800s, and the 3620. And then for suction caisson type jacket or tripod foundations, you would have a modified OPC. Essentially, a modified OPC for suction caisson is a strength class of anywhere between 1 to 5 MPa. So it doesn't really set like a cementitious grout we would expect it to set. It forms more like a clay, which is then easily removed at decommissioning. All of the data sheets for these products can be found on our website, and along with other case studies as well. So for monopile foundations, fully grouted, structural grouted TP, we would expect to see the Ducret S5, the 9500, or the Shifu grout, or the Seeker grout 3500. All of these are ultra high strength grouts. For the bolted and the grouted, in this round, you would see Masterflow 9600, and we're seeing increasing interest in the use of OPC, particularly where the grouted connection is subsea, and so dry and shrinkage doesn't really become an issue because OPC is not compensated in any way. It is just a neat ordinary Portland cement mixed with seawater. So it does suffer from a slight dry and shrinkage at the leading edge of the grout phase. The bolted TP, no grouting at all, and the monoblock, no grouting, although there is potentially an opportunity for low strength grout with the underbase grouting. So from our perspective, the things that the EPCI or T&I contractor should be aware of for the logistics and offshore operations of grouting. How easy is it to get the material to the marshalling yard and the offshore work site? How will the material be stored at the marshalling yard? What is the shelf life of the material? And how quickly can it be mixed and pumped to the foundation connection? And does the material need a DMV type approval certificate or just track record? And then what are the implications over one material type to another? These are all questions that that we're asked at the beginning of a tender process, and we're asked our opinion on. And as I say, these are just our opinion. They're not in any way the typical opinion of other companies. So if I take each one of those points, how easy is it getting the material to the marshalling yard and the offshore work site? So for European projects, the supply to the marshalling yard is fairly straightforward. Most of the proprietary construction grouts are manufactured in either Denmark, Germany, or Belgium. And OPC is manufactured in most, if not all, European countries. They're delivered in bulk or big bags. Much of that, all of that type of grout. And for the offshore work site, this depends on the mixing process that's going to be used. And essentially, there's two methods: batch and continuous mixing. Batch mixing the material is predominantly delivered in big bags, and continuous mixing the materials delivered in silo. I say predominantly delivered in big bags because there are instances where you could have an auger-fed system delivering a certain weight or mass into a mixing pan. So it takes the big bag concept away and uses silos, but predominantly any batch mixing process is typically done with big bags. How will the material be stored at the marshalling yard? So most material manufacturers recommend that the bag should be stored in a cool and dry condition. And prior to load out to the vessel, the material may need to be loaded into suitable offshore containers. The offshore containers are loaded onto the vessel during resupply. Material delivered in bulk, typically the material is pneumatically transferred from the road bulk tanker to waiting offshore or dedicated onshore silos. And during the vessel's resupply, the silos are either exchanged with the empty silos on the vessel, or the material is pneumatically transferred from the onshore silos to the empty vessel silos. What's the shelf life of the material? Well, pretty much 6 to 12 months. And there are, in many cases, very long lead times with construction grouts, which can lead to problems if projects do get delayed. OPC, again, typically 12 months, as long as it's stored correctly. And as the delivery time for OPC is typically around 2 weeks, less material stock is required at the marshalling yard, particularly if the manufacturing site is close. How quickly can it be mixed and pumped to the foundation connection? This is important because you want to keep your operations to an absolute minimum on the critical path of the vessel. So material delivered in big bag, that can be anything from 6 cube an hour to 20 cube an hour with the pan mixer and super pan mixer, and variations of these things available on the market. These are batch mixing equipment. Material delivered in bulk, This can range from 14 cube an hour to 45 cube an hour. Now, this is construction grouts. This isn't OPC. If we were talking about OPC here, we would be at nearer probably 70 to 80 cube an hour with OPC, and certainly 30 cube an hour with a recirculating jet mixer. So does the material need a DNV type approval certificate or just track record? And this is an important consideration and really depends on who the licensing authority is. In Germany, although DNV certified materials are preferred, track record on previous projects offshore Germany is also being given consideration by the BSH. What is important to say is that allowing the use of non-DNV certified materials certainly opens up the choice and lowers the overall costs. By way of an example, to our knowledge, there's been no issue on Ormond offshore wind farm, Thornton Bank 2 and 3 offshore wind farms, and Balkan West, all of which were grouted with an ordinary Portland cement, which was non-DNV certified, but was back in 2010 to 2012, quite a few years ago now. What are the implications over one material type to another? So big bag materials require a crane to lift the bags into the mixer. Construction grouts require fresh water, whereas OPC is mixed with seawater. This would mean for a 20 cube connection, as much as 7,000 litres of fresh water could be required for a construction grout, and this would need to be supplied from the vessel's main water supply or held in tanks on deck. The mixing of the material and the delivery of the grout to the connection is typically faster with bulk supplied material. Bulk supplied material is less prone to being affected by weather, i.e. crane operations, which may be limited in high winds. And typically construction grouts are more expensive due to the lower yield and higher price per tonne than OPC. So the last couple of slides, I would just like to talk about the Beatrice offshore wind farm. This was grouted by Foundocean with support from its partners back in 2017. The general overview was that it was a wind farm with green energy to power over 450,000 homes. It's located in the Murray Firth in the North Sea and was a joint venture between SSE, CIP and Red Rock Power Limited. Foundocean managed the onshore logistics and offshore grouting for the 84 turbines and 2 offshore transformer module foundations. And it was the first time a high strength material was stored and transferred via silo storage on this scale. The time to grout was reduced because the material was designed for use with the super recirculating jet mixer rather than the conventional pan mixer. The foundation design was a 4-leg foundation. Each leg was located in a pre-installed pile, and the grout lines ran through the jacket legs. The material choice, as I said, was very important. They needed a high-strength grout. Preference was for it to be bulk supplied to optimize deck space and continuously mixed to meet the project schedule. So Masterflow 9800, which was the only material at the time, was chosen for the project. Offshore operations, it was a 24-hour operation, and the material quantity per foundation was 143 tonnes, which made a total material quantity for the project of 12,300 tonnes. The average grouting rate was 3 jackets per 24 hours, and we took over 6,000 cubes for our QA procedures. Onshore operations and logistics. So Foundocean provided the quayside coordinator for single point contact. The material was shipped from Germany to Rotterdam. And with our partners, we provided approximately 1,000 tonnes of onshore storage. This enabled the project to run smoothly and to take into account flexing of the schedule. The material was pneumatically transferred to the resupply vessel during port calls in the vast majority of time. There were other instances where smaller silos were lifted and replaced with on-deck silos, but the vast proportion of the material was pneumatically transferred. And we provided material tracking using our batch track system, which is an important part of using construction grouts that are DNV certified, as you need to be able to show an audit trail from point of manufacture right through to the connection on the foundation. So that's me. Thank you very much. And I will hand back to Mikhail or Yanis.
Thank you, Andrew, for your brilliant presentation. And so this is the moment for questions. So if you have any questions, please put those in the chat. We still have some time to do that. If not, you have my email address or Janusz, so please send the question. Or if you'd like to have any meetings, like to meet with Andy, Eric, and any other guys, please let us know. We'll be happy to do that. And I still don't see any questions. So taking this opportunity, I would like to invite you all to our last webinar, technical webinar before summer leave. On the 15th of June, we'll talk about procurement, project management, etc. So we'll be sending you an invitation letter later today, and agenda will be updated in the next few weeks. So I hope we could see you there. And of course, after the summer leave in September, October, we'll continue with series of our technical webinars. Janusz, not sure if you want to add something.
No, thank you. I just want to say thank you to all who spent this morning with us. Thank you for your time and wish you a good day.
Thank you, Janusz. So, are there any questions? It was a pleasure to host you. Thank you to our Scottish and British speakers. I hope we could invite you to our event, and thank you for our audience for staying with us for 1.5 hours. And I hope we'll meet soon later this year, but also hopefully after going out of the lockdown during the event and reception in Warsaw and Poland. Thank you very much again, and have a nice and productive day. Thank you so much.